Hello, greetings of the day. I am Vinaya Tapkir, Assistant Professor from MIT Academy of Engineering, presenting here the next Ready List Table Part 2 video, which is in continuation with the Ready List Table Part 1. In the previous video, we have seen the OS RDY GRP and the OS RDY table of array, which are the two important structures used by the kernel to decide which priority task is ready to run. So all theoretical part we have covered in the part 1 video. Now we have to see the numerical here, how the scheduler or how the kernel can understand which priority task is ready to run. Because we know the MUCOS 2 is a multitasking kernel, there are multiple tasks are running simultaneously and processor has to keep the track which task needs the access of the CPU because the CPU is only one and tasks are multiple. So the CPU or the kernel give the proper scheduling or the proper service to the particular task which is ready to run. And as per the priority also, we have seen the MUCOS 2 is a priority based kernel. So always the MUCOS 2 has to keep the track whether the any high priority task is ready to run than the low priority task. For do to complete or to control all these activities, the kernel is taking the help of the ready list table. So we will see one numerical for that. This is the example one. Here, the value of the OS ready GRP suppose contains the value 011010000 binary, or we can say this is the 0x6 set in hex. So OS ready RDY GRP value is loaded by the kernel, by the scheduler when there are multiple tasks are ready to run. Then the kernel has to read this value and it has to take some decisions. What decisions or what operations the kernel is carried out, that we have to see here, and then calculate the value of the x and y and what is the priority of the task is ready to run. So this is our example. Again I am reading this example. OS RDY GRP contains 011010000 in binary or 0x6 set in hex. Then calculate the value of x and y, which are the coordinates of the OS RDY table, and what is the priority of the task is ready to run. Means what is the priority of the task which kernel can understand ready to run. So there are the two steps to solve this. Means kernel is following these two steps or the two masking procedures to understand the value of the priority which is ready to run. So this is the one more structure is taken into account here, that is the OS unmapped table. Unmapped table of OS RDY GRP. Means the OS RDY GRP value is taken as an input for this OS unmapped table. So what is this OS unmapped table? This is the unmapped table which is holding the 8-bit value. Every value, all these 8 bits are indicates the index of the particular GRP value, because every index or every bit from the GRP group is presenting or indicating that any value from the OS TCB table is ready to run. So we have to find out that index first. So this is the mask table is there. This 0000001 indicates the index 0. 0000010 indicates the index 1. 0000100 indicates the index 2. Similarly, this is the index 3, this is index 4, this is index 5, this is index 7, and this is index 6, and this is index 7. So each and every bit from the bit mask value indicates the index value from the OS RDY group. So indicates the index of the OS RDY GRP. For that, the kernel has to perform the masking operation, and you know that the masking is nothing but the ending operation. So what the scheduler is doing or what the kernel is doing, it is taking the value of the OS RDY GRP as an input, and the kernel has to perform the masking operation. Means the kernel has to perform ANDing operation with all these indexes so that the kernel can take it out the which actually the index first index which is telling that any one priority from the OS RDY table is ready to run. So every time, at the every instant, the kernel is taking the value from the OS RDY GRP, and it masks that with the every index of the OS unmap table. So here, first it has to unmap with the zeroth index, first then first index, 2 and 3. Here I have directly shown the third index. Okay, so whenever it will map the value or and the value with the third index, then the kernel will get the 1 and 1, that is the value 1 here. So this is called as a masking in the binary language, in the digital language, or ANDing operation. ANDing operation helps to give the value 1 out of from the two ANDings. Okay, so yeah, now here I will get the value directly at the third index as a 1. So that I can say that the third index from the OS RDY group is telling that telling that any one bit, the value indicates that bit 3 is 1. Hence, any bit in the OS RDY table of 3 is 1. कौन सा bit that we don't know. Any bit from the OS RDY table is 3 is 1. So this is our next step now. Now we have got the idea that OS RDY GRP value is a 011011000. This one indicates the any value from the third group is ready to run, and this value is extracted by the kernel using the unmapped table. Now after extracting this, kernel can understand any bit from the row 3, that is y is equal to 3, is ready to run. Hence the value of from the step 1 we got it as a y is equal to 3. So initially function yields y is equal to 3. So we got the y is equal to 3 now in the step 1. Now which is the correspond to the bit 3 in the OS RDY GRP. Now hence the task is in row 3 is ready to run. Any task from the row 3 is ready to run. So what we have to follow this next step? Now if OS RDY table of 3 contains 111. Now OS RDY table of 3 means this value. This is also again the 8-bit register. Now if OS RDY table of 3 contains 111 means here 1 1 1 0 0 1 0 0. This is the value of OS RDY table of 3. Okay. Then what step again followed by the scheduler? That is the step 3. Now in the step 1 we have done the masking of the OS RDY GRP. In the step 2 we have held the value y is equal to 3. And now here in the step 3 we have to take again apply the OS unmapped table for OS RDY GRP of 3. Hence, what is the value of the OS RDY GRP 3? That is the 111001000. Then the scheduler will mask with every index of the OS unmapped table with this value. And at this stage, means at the second stage, we will get the result of the ANDing as a 1, so that the scheduler can understand value of x is equal to 2. So here also the masking is done. What is the value? 1 1 1 0 0 1 0 0, and when it will get ended with the 0 0 0 0 0 1 0 0 means that is the second index. Then the result of the ending tells that this value at the second index is 1, and this tells that the any priority from this second bit from the table of 3 is ready to run. So this gives me the value as a 2. So what is the position here? Y is equal to 3 here, and x is equal to 2 here. So this gives me the idea to the scheduler that this is the coordinates, or this is the position where the value is a 1, so that the kernel has to calculate the priority of that. 26 is not stored here. 1 is stored here. Then kernel has to calculate the priority using this formula. The task priority is y into 8 plus x. That is equal to, here y value is a 3 and x value is a 2. So 3 into 8 plus 2, it gives the 26. In this way, the scheduler is calculating the priority of the task which is ready to run. because this table only holding the values as a 0 1. This group is also holding the values as a 0 1. So using this formula, scheduler has to calculate the actual priority number and decide which priority is ready to run. Hence, at last and not least, that there is a one task priority register which holds the value of x, which is the 2 here, and value of the y, which is 3 here. With the help of this, the kernel can puts the value in this formula and calculate the priority. So this is the first example. In the next video, we will take the second example. Thank you all of you.